Swayam Prabha. Digital India. Educated India.
Good morning everybody and welcome again to our course on Introduction to Mechanical Micro Machining. In the last class we have seen some of the components of the machine tool such as the construction or the structure of the machine tool, spindle system, then we need some type of drive system also. In that way we understood that we have to be very careful in selecting of those components and we have to assemble in a perfectly shape, otherwise you cannot get the required shape out of the machining zone. So, let us continue this topic ahead, and we have also seen that there are different components, stationary bodies and the moving bodies, and moving bodies, stationary body will carry the moving body so that they can move from one location to another location to get the things done. So, when you consider the machine design of a machine as a system, there are some major design issues are available. So, those things are stiffness and the damping, because now we know that when you do machining at a micro level, your stiffness of the machine tool should be very high. So, if this is not very high, then we know that it will propagate vibration or it will create a problem in the permanent deformation of the components. Damping is also important, because if it will not damp the vibration within the system, then vibration will be propagated into the different component of the part. So, suppose consider that this is your tool position and this is your workpiece position, this is your contact zone and this is the whole things which are connected with this, and this is the location from where you are getting a vibration, right, vibration. So, now what is going to happen with the vibration? That vibration will move in this direction also and it will move in this direction also. Now, going to that, if it is moving in this direction, there is a spindle system available, spindle system, and then it will move to the column, and from if it is going in downward system, what is happening here? There is a fixture and then it is going toward the guideway and then it is going to the base, correct. So, in both the way, when it is propagating within the system at that time, it is not good thing for the machining operation. So, what material you have to use for construction of this thing, that is dictated by the this particular damping and the stiffness. More is the quality of the damping and stiffness, more will be the precision of the machine, but again problem is the cost. That means, you have to again break even with the cost, so that extra things should not be added without looking into the cost of the machine. Structural configuration is also important. The which type of configuration, open loop structures configuration available, closed loop available, overhang available. We will see those things in next 2 to 3 slides. Structural connectivity is important. So, this is called the structural connectivity, because we know that spindle is tool is connected with the spindle, spindle is connected with the spindle housing, housing to the column, and from the workpiece side, workpiece is held within the fixture, fixture is fixed to the XY table, XY table to guideways and guideways to the base. So, these things are called connectivities. So, if these connectivities are not completely rigid or not too much tight at that time, you may get some type of problem during machining, and that few microns here and there will also create the same impression onto the workpiece dimensional accuracy, and you will get some error in the final geometry. Structure dynamic performance, that means when you are operating the machine, at that time what is happening to the structure. So, thermal stability is important, because we know that there are many moving components which are in physical contact. That means, if you are using air bearing, there is no physical contact, oil bearing no physical contact, but when you are using a ball bearing or some other bearing where there are physical contacts. So, because physical contact and all are in motion, so at that time it will create friction, and because of frictions you will get the increase in the temperature. And when this is there, the temperature stability is more important here. because we know that each and every material has the coefficient of thermal expansion at some value, and that value is important to understand the stability of the machine under the different variation of the temperature. Response to the external forces is important. External forces, that means suddenly you are starting machining operation, because now if you consider that your workpiece is here located and your tool is here at this location, and this is your tool has to move from one to this location to start the machine, right. So, when it is moving here, it is called dry run or the air run. Right. So, this is called the dry run or air run, where you are not doing any type of machining, but as soon as it is touching the surface, suddenly it is encountering the material. So, material will resist that particular deformation. So, at that time this will consider as a external force also, that means suddenly you are touching the surface and then it is getting deformed. So, what is happening, that what is the structural stability when it encountered this type of external forces? That means when two vehicles are in motion and when they are colliding with each other, at that time how much is the stability of the car or the truck, so that you cannot get any type of problem within the passenger, whatever is sitting inside the car. So, same thing happens here also. When this external forces acts, our structure should be rigid in such a way that it should not deform to a very lower level, so that you can further use the component of machine without any problems. Now, with regard to the proper functioning of the moving axis and operational stabilities, what we need, that we need a high structural loop stiffness. We will see this thing, what is the structural loop stiffness. It should be high. High structural loop stiffness means whatever the assembly is there from tool side to down side and tool side to up side and the workpiece side to the down side, all things should be rigidly work against the forces acting onto the tool and workpiece. Good damping property, that we have seen that once the vibrations are generated, it should diminish within the local area only, it should not propagate within the system. So, that is also important, that is good damping properties. Symmetry and closed loop structural configuration. Symmetry, that means when there is a temperature variation. Now, I will show you one video probably in the next class or during that sensor and monitoring part. Suppose we have one system here, okay, and this is the center line of the component, and you have mounted your spindle here at this location, correct. So, when you are coming across the different temperature variation, that means there is a huge temperature variation. So, what is going to happen? So, these things will expand. If your spindle is located at the center point of this, even though there is expansion of this, nothing is going to happen with this particular thing, because still it will remain at the same location. But now consider the same thing is there. Consider this is the axis and you have mounted your spindle here at this location, correct. Again there is a temperature variation and there is expansion of this part. So, when there is expansion, what happens? This spindle axis will shift in this direction little bit. So, now your location of the axis of the spindle is different. So, symmetric structure is very important. We will see that how temperature variation will create a problem if your structure is not symmetric. Closed loop is important, because overhanging structure is something like that, whatever we have seen in the most of the cases. So, this is the overhanging, this is your workpiece and this is your tool, right, and this is over, that means whatever is this part is overhanging. But if you construct in different way, we will see one figure here, that is called the closed loop configuration of the system. Thermal elastic structural loops. So, thermal loop, elastic structural loop, we know the elasticity, that means when you apply the load, your structure will deform, but when you remove the load, again it comes to its original position. So, thermal and elastic loops are also important, because when you are applying the force, it may deform, but your machine tool is intelligent enough by using some sensor that whatever is the elastic deformation is there, your machine understand, it will compensate with the tool. And thermal deformation should also know that we know the what material we have used for the construction of the machine, we know the thermal coefficient of expansion, then we actually calculate any deformation, contraction or the expansion depending on the temperature change, and machine will take its own decision that how much is the movement or the deviation from the actual location of the XYZ location to the other location because of the thermal load and the elastic structural deflection. That can be decided, but that will also again comes against a cost. Minimization of the heat deformation, because we know the temperature variation is very important and we are working with the physical processes. That means, there is a physical contact between the tool and workpiece, and once this happens, at that time there is a problem in the actual machining and the dimensional stability of the component. Isolation of the environmental effect, that we have seen that the machine should be mounted or installed in such a way that there should not be any other installed. So, this is the machine installation. So, there should not be road passing through this part where the vehicles are moving. So, this should not be the case. You cannot install under machine. Under machine with vibration tendency. So, this thing should not be also there. You need a proper foundation, vibration isolation. Vibration isolation, correct. And then another thing is the temperature variation. You have to maintain the temperature also within one particular limit. So, those things are called the isolation of the environment, correct. Humidity also you have to maintain, not only temperature, humidity control. Correct. So, these are the things which are not directly connected with the machining operation, but these are the external things which will also create problem in the dimensional accuracy of the machine. Now, before we go further in this thing, I have taken some of the material from Professor Shokam's slides, because now I got one information that he is proposing one course on the precision engineering for rapid product development, where you can find out that what we have to do to get the break even between the precision and the cost, because we have seen in earlier few slides before that if you increase the level of precision or performance, your cost will also go very high. So, you have to find out that how much you have to spend on to the precision with respect to cost. That means, cost should not be so high that you have to do a compromise with the cost. So, this course will be floated on the in July 25 to 29, and you can register this course on this particular website. So, this some of the things I have included in this particular course. These are very limited, but for more detail and more rigorous understanding about the robust design and the high quality products, then you have to go through this course. That is very useful to understanding this precision machining and the error level. So, some of the slides I have taken here. So, this is Professor Alexander's website, where you can find the kinematic couplings, and this is the website. You will get a lot of information about those things. I have taken something which are more relevant to this course, and you can understand rest of the things from their website. So, what are this accuracy, repeatability and resolution? Because we know that when you are working with a micro domain, you have to understand that how each and every parts are affecting the machining operation. So, we know these particular things in terms of metrology or the instrument part. That means, what is the accuracy of the particular instrument, that suppose you want to measure temperature variation, you want to measure dimension of any component by means of vernier caliper or something. At that time, you have to understand accuracy, repeatability and resolution, and these things are important in all the measurement, right. So, here let us see that how these terms are connected with the machining operation or the micro machining operation. So, these terms are often used in the precision practices. So, first thing is the accuracy. So, now what is the accuracy? How we can define accuracy? Accuracy is the ability to tell the truth. That means that suppose you are at one location and you want to identify that location, that means how closely you are going to that location. So, that is given by the accuracy. What is the repeatability? That it is the ability to tell the same story each time. That means, if one person is asking something, then you are telling something. If other person asking same question, you have to tell the same story. If you are not telling the same story, that means there is a problem with the repeatability. There is a third one, it is called the resolution. What is the resolution? This is the detail to which you tell the story. Now, how small you can go inside it, that will be decided by the things, then that is very, very important in this case. So, these three terms are very, very important in machine tool also. So, we will see this each term very, very detailed in this part. So, now consider this is the target point. We want to go to this location. Instead of that, what we are getting, we are reaching to this location somewhere. So, here important thing is that once you get this location, you are away from the target location, and this is creating a problem. So, now you are away from the target. So, what things are there? So, this is the position achieved while attempting to position to a target point. We want to go to this location, we are reaching to this location, and these are the black dots are the different points. That means, instead of that, you have done around 10 types of operation, and everything is spread around this location. So, this is the center point of this particular variation or the distribution of that part, what you are getting here. So, this is called the accuracy. So, more is this thing away from that, less is the accuracy. More this thing close to the target point, more is the accuracy, correct. So, this is the way you can define the accuracy, the ability to tell the truth. So, how close you are reaching to the target point, that is that thing. Then repeatability, that how much time you are getting this result here. So, we have many readings here. So, these all things, suppose you consider this is within the tolerance limit, that whatever dimension you are getting, which is within the tolerance limit. So, that means this is a repeatability. So, all things are falling within this particular band. So, if you create a radius out of it, all things are within that part. So, this is called the repeatability. So, how many times you can tell the same story? So, this is the center point of that, you are telling everything around that part. So, if this is acceptable, your system is repeatable. Now, once this part is over, suppose you have done lot of readings here, you are changing the component and then you are doing same operation, then you are getting some other location. By chance you are not getting the same location. So, what is this thing? So, same thing again, the position achieved while attempting to position to a target point, same thing is here, position achieved while attempting to position to a target point, but plus the finest increment of motion which can be programmed, correct. So, now what happens that this is the one thing you are getting in first operation, you are getting this thing. In next operation, what you are getting, you are not going to this location, but by chance you reach to this location. So, now this is also different from this part. So, now you consider this accuracy is still same. Suppose you consider distance between this point, this point, this point, these points are same, then accuracy is same, but problem is that how far it is located from each other, correct. So, this is called the resolution. So, this is the finest increment, suppose it is within that range, then this is the location of this particular part. So, you are getting something within this part, and this is called resolution. If it is this particular circle is close to this thing, that means it is high resolution, that means within a small movement it can detect the things of whatever things are changing. If it is located here is this location, the resolution is low, here the resolution is very, very high. So, I think now it is very clear in terms of the machining operation, micro machining perspective, that accuracy, repeatability and resolutions are very, very important during the construction of the machine also and during operation also. Now, let us go through one by one. So, what is the accuracy? In terms of the machining operation, let us not talk about the instrument point of view. So, ability of a machine to move to a commanded position which is not visited before. Now, consider that your tool right now located here. So, this is the first location and you have instructed the machine by a part program that you want to go to this location, correct. So, this is the target location. Now, it is starting from this and it is moving in this location. This location actually it was not visited before that. So, how close it is reaching at this location, that is decided by the accuracy. That means, all the components, whatever components you are using, all the drives, XYZ drives, then you are using encoders. So, everything will work in such a way that you can reach to that particular location. So, machine calculates the new position in terms of its feedback system parameters. So, now when you command this particular tool, so that your tool is moving from here to here. So, first thing is that it has to move up to this dimension. Consider this is in x direction. So, your program or the GNM code will command your tool to move x direction up to this location, then move into the y direction, and then again move into the z direction. So, when you are moving and you are reaching to this location, your feedback system will give you information to the controller that it has reached to the x position. That now it will move to the next line, then it is moving in y line, y direction. Again your feedback system will give information that your tool has reached to the y location, and then it will move to the x axis again, right. But that does not mean that the machine is shown or taught the position and the feedback parameters are stored. Now, see, in robotics application, many times what happens that there are ways of doing these things. Suppose you are right now at this location, you have one workpiece and your robotic arms want to pick up this is the workpiece and this is the robotic arm location, and your workpiece is located here, and you are instructing robot to pick up this arm, pick up this workpiece from here. So, many times what happens that this locations is already known to the robotics application. Then what it will do? It will do a back calculation that which is the easiest way to get this thing done. But that is not done here in this, because in our case it is altogether opposite direction, that these things is not known. Where is this point located is not known. So, that is the reason that you are moving in a such a way that you are reaching to this location in a efficient manner. Right now it is showing in this location, but this direction, but you can directly reach to this location by this way. So, at that time you have to move x and y simultaneously. If you want to move x independently, y independently, then this is the way of reaching to this location. But how closely you reach to this location, that we have seen here, the target position is different, and when you are reaching that may be different, but then the whatever the accuracy of this thing, that will be decided by that. So, this is not working in terms of the robotic application where you already have information about this particular point, and then your robotic arm will follow one particular optimized path to reach to this location. It is not like that. Our case, it is a open loop thing. That means, we know our controller only to reach to this location. This position is not known, right. So, accuracy brings the entire machine hardware and controls to bear on the task. So, now what is the important thing here? That again we want to reach to this location. So, we know that each and everything is important. Now, what is the task of the component? So, this is all the task, that means machine, entire machine, that means the construction of the machine is important, because if there is a deformation, then you are end up with the wrong location at that part. Hardware is important because hardware related to all the XY direction movement, that means whatever things you are adding, the servo motor you are using, stepper motor you are using. So, those things are hardware. Controller, that means what things are rotating or moving these particular motors. So, those things are what variable frequency drives, and those things are there, and these all things will work, and if all things are working 100% of their capacity, there is a high chance that you will reach to the target point. If even one of these thing is not working at 100% capacity, high chances are that you will end up with the wrong location, maybe here, here, here or here, any direction it may happen. So, that is the problem. So, what is the importance of accuracy? That if you tell that your machining accuracy is very, very high, you can understand that all parts are working fine, right. If one part is not working fine, you will not get accurate machining during the operation. So, this will bring all the system, whatever is included within the machine tool, all things are responsible for getting a high accuracy of the machining operation. Another thing is the repeatability. So, what is the repeatability? It is the ability of the machine to revisit a location and has another implication, including from which direction is the movement made, right. So, now let us see this thing. So, now this is our target position. Okay. And our cutting tool is right now at this location. This is our cutting tool. Let us consider our cutting tool is this location. So, it is moving in this direction, correct. Now, in next operation, now this is depending on that revision location and other implication, including from which direction movement is made, right. So, right now our direction of movement is this one, correct. So, now it has reached to this location. Consider this is your reference point through which you are actually making a different machining operations. So, this is your reference point, and second part, suppose your tool is located here at this location. Now, your machining or the direction of movement is in opposite direction to the earlier case. So, now consider that if your tool is moving from this to this location, it is reaching to the target location. If your tool is moving any direction other than this direction, then again it should reach to the target location, right. So, how it is defined here? So, this is depending on that. So, now there is a two things, one is the repeatability and another thing is bidirectional repeatability. So, if the point is approached from the two direction, so whether you move from this direction or any other directions, it should reach to that particular location or revisit the location again and again. So, that is called the bidirectional repeatability. But this is very difficult to achieve than the only repeatability. Why? What is the problem with it? Because there is a problem with the hysteresis motion. So, that is creating a problem, and other thing we can write it is a backlash, right. What is this backlash here? Because now consider that suppose you have a lead screw, something like this. Right. So, this is connected with a motor, correct, and we have one table which is mounted on the top of it. So, this is considered as a table . Right. So, when you are rotating this screw, at the time what happens, that your table is moving in this direction. Suppose you are rotating this screw in this direction, your table is moving in this direction. So, at the time when it is moving in this direction, you have contact at this location, correct. So, when it is a contact, it is moving in this direction continuously. So, you are moving your tool from this location to this location. So, this is your target location. Okay. So, now your starting position is this one and you are reaching to this location, you have reached there. Now, you are rotating your motor in the opposite direction in such a way that you want to move to the original location. So, this is the target location and this is the origin. So, when it is moving in this direction, this is called repeatability. Suppose you are reaching this location in one direction, then you are calling this tool back to this location. Now, what is the problem? Now, consider this particular zoom part. I am zooming this thing a little bit. So, this is the lead screw, and now this is the level, because when it was moving at that time there was a physical contact here. When it is moving in opposite direction, what happens, that this is creating a problem. So, whatever this gap is there between the inner face of this lead screw and this notch, whatever that, this is called backlash, right. So, when it is rotating in opposite direction, for a small amount of rotation, your lead screw is rotating, but your table is not moving in this direction. And suppose you have added here rotary encoder for feedback, getting feedback out of it. When motor rotates, your rotary encoder will tell you that your motor is rotated, so your table has moved from this location to this location, but actually your table has not moved in that direction. So, because of the backlash, your rotary encoder will calculate wrong position, and because of that you are end up with drilling or doing machining at the wrong place. So, this is the problem of the bidirectional repeatability. There are many ways you can actually avoid or you can minimize this thing, that by using a different recirculating ball screw mechanism or using linear encoder in place of rotary encoder, but these things we will discuss in the few class later. Okay. So, let me finish this class today, and this topic will continue further in the different aspect of the machine tool in the next class. Thank you very much.